Hello there, gentle wanderer of the night. Thank you for finding your way here to this quiet corner where science meets wonder and curiosity dances with dreams. Tonight, we're embarking on perhaps the most extraordinary journey possible, one that will take us to the very edge of reality itself, where time stops dancing and space holds its breath. We're going to explore what the universe looks like when you're traveling at the speed of light, that magical, impossible speed that governs everything from the starlight touching your face to the very thoughts flickering through your mind. Imagine, if you will, riding alongside a beam of light as it journeys from distant stars, experiencing reality as photons do, in a realm where our everyday rules simply dissolve. I'm curious, where are you listening from tonight? Perhaps tucked under soft blankets, or maybe gazing out at the darkness through a window. And what time shows on your clock right now? Is it the deep quiet of midnight, or those precious early morning hours when the world still sleeps? If this gentle exploration brings you any comfort or wonder, I'd be grateful if you'd consider sharing a like or subscribing, not because you have to, but because it helps these whispered conversations find other curious souls wandering through the night. How is you fine? Fair warning though, I find this topic so fascinating that I might get a bit too excited about photons and time dilation. I'm supposed to help you sleep, but the universe at light speed is just so wonderfully strange that I can't promise I won't get carried away. So settle in, let your breathing slow, and prepare to see reality through light's own eyes. There's something almost magical about the number 299,792,458, not because it's particularly beautiful to look at, though I suppose any number can be beautiful if you squint at it just right, but because this number, measured in meters per second, represents something far more profound than mere speed. This is the speed of light, and it's not just fast, it's the cosmic speed limit that reality itself has chosen to obey. Imagine for a moment that the universe is like a vast symphony hall, and every law of physics is a musician waiting for the conductor's baton. The speed of light isn't just another musician in this cosmic orchestra, it's the conductor itself, setting the tempo for everything that exists. When electrons dance around atoms, when stars are born in distant galaxies, when your heart beats in your chest, all of it happens in perfect time, with this fundamental rhythm. You might wonder why this particular speed is so special. After all, it seems almost arbitrary, doesn't it? Like someone just picked a really big number and said, there, that's how fast light goes. But here's the beautiful secret. This speed isn't just about light at all. It's about the very fabric of space and time, woven together in a cosmic tapestry that Einstein helped us begin to understand. Think of it this way. Imagine you're walking through a gentle rain, and each raindrop represents a moment in time. Now imagine that the universe has decided that information, energy, and influence can only spread from one raindrop to the next at a certain pace. That pace, that cosmic stepping stone from moment to moment, happens to be exactly the speed that light travels. It's as if the universe itself has a heartbeat, and light simply moves in perfect sync with that rhythm. What makes this even more wondrous is that this speed limit applies to everything that carries information or energy from one place to another. Gravity moves at this speed. When a star explodes, its gravitational influence doesn't instantly disappear everywhere in the universe. Instead, the news of its demise spreads outward like ripples on a cosmic pond, moving at exactly light speed. Even the forces that hold atoms together respect this cosmic speed limit. In the darkness around you right now, countless photons are streaming past, some from your bedside lamp, others that have traveled for years from distant stars, all moving at exactly the same speed. They're like cosmic messengers, each one carrying a tiny piece of information about where it came from and what it encountered along the way. And every single one of them, without exception, travels at this fundamental speed that governs reality itself. Phi. So when we talk about the speed of light, we're really talking about something much grander. The speed at which cause becomes effect, the pace at which the future emerges from the present, the rhythm that keeps the entire universe dancing in harmony. It's not just a speed, it's the universe's way of keeping time. Light. in its endless journey across the cosmos, serves as the universe's most faithful messenger. Every photon that reaches your eyes right now, whether from the soft glow of electronics nearby or the ancient starlight filtering through your window, carries with it a story that began somewhere else, someone else. Picture light as a cosmic postal service, but one that never loses a package and never fails to deliver. When a star burns bright in a galaxy billions of light years away, it entrusts its message to countless photons, each one carrying a tiny piece of information about that star's temperature, its chemical composition, its age, and even its motion through space. These photons then begin an epic journey across the void, traveling in perfect straight lines unless something bends their path. A planet, a black hole, or even the gentle curvature of space itself. But here's where light becomes truly magical. It's both wave and particle at the same time, like a cosmic riddle that reality refuses to solve simply. As a wave, light flows and ripples, carrying energy in its oscillations like a gentle ocean that spans the entire universe. The color you see is determined by how quickly these waves oscillate. Red light waves move more lazily, like a slow, peaceful breathing, while blue light waves dance with quick, energetic steps. Yet, when we look closely enough, light reveals its particle nature too. Individual photons zip through space, like tiny packets of energy, each one carrying exactly the right amount of energy for its particular color. A blue photon carries more energy than a red one, like the difference between a whispered secret and an enthusiastic shout. This dual nature isn't light being confused about what it is. It's reality itself being more subtle and complex than our everyday experience suggests. What's truly remarkable is how light carries information without ever getting tired or slowing down. A photon that left a star 1 million years ago arrives at your eye with exactly the same energy it started with, assuming nothing absorbed it along the way. It's like receiving a letter that was written eons ago, delivered by the most reliable postal service in existence, one that never takes breaks, never gets lost, and never gives up. Light also serves as our cosmic clock. When astronomers look at distant galaxies, they're literally looking into the past, seeing those galaxies as they were when the light left them. The light from our sun takes about 8 minutes to reach Earth, so we always see the sun as it was 8 minutes ago. In a very real sense, light creates a natural time machine, allowing us to witness the history of the universe simply by looking far enough away. And in the darkness of space, light travels alone, carrying its message across vast emptiness with patient determination. Unlike sound, which needs air or some other medium to travel through, light needs nothing but space itself. It's perfectly content to journey through the vacuum, like a wandering monk who has learned to find companionship in solitude. Each photon is also remarkably democratic. It doesn't matter if it came from a mighty star or a simple candle flame. They all travel at exactly the same speed. The universe doesn't play favorites when it comes to light, whether it's the gentle glow from a firefly on a summer evening or the brilliant flash of a distant supernova. Every beam of light obeys the same cosmic speed limit with perfect, unwavering consistency. There exists in our universe something like an invisible wall, not made of stone or metal, but of pure physics itself. This is the barrier of light speed, and it stands as one of the most absolute laws in all of nature. Unlike human-made rules that can be bent or broken, this cosmic boundary remains perfectly, immutably firm. Imagine trying to push a shopping cart that gets heavier and heavier the faster you try to move it. At first, it rolls along nicely with just a gentle push. But as you speed up, something strange happens. The cart seems to gain weight, requiring more and more force to accelerate even a little bit. Now imagine that this effect becomes more and more extreme until pushing the cart just a tiny bit faster would require all the energy in the universe. This is essentially what happens to anything with mass as it approaches the speed of light. Einstein's beautiful and relentless mathematics shows us why this wall exists. As objects with mass move faster and faster, their energy, and what we might call their effective mass, increases dramatically. Not in a gentle, gradual way, but in a curve that rises steeper and steeper. like a mathematical mountain that becomes infinitely tall at exactly the speed of light. To push even the smallest particle with mass all the way to light speed would require infinite energy. And since the universe doesn't keep infinite energy lying around in its cosmic wallet, this journey becomes impossible. This isn't a limitation of our technology or our understanding. It's a fundamental feature of reality itself. The universe has essentially said, this far and no farther when it comes to massive objects. It's like having a cosmic bouncer at the door of the Light Speed Club, politely but firmly explaining that if you have mass, you simply cannot enter. But this barrier isn't arbitrary or cruel. It serves a deeper purpose in maintaining the logical structure of reality. If massive objects could travel faster than light, the careful order of cause and effect that keeps our universe sensible would begin to break down. We might see effects happening before their causes, like watching someone react to a surprise before the surprise itself occurs. The universe seems to prefer keeping things in proper order. What makes this boundary even more fascinating is how sharp it is. There's no gradual transition zone where the rules get fuzzy. You're either traveling slower than light, in which case you experience time, have mass, and exist in the familiar realm of matter, or you're traveling exactly at light speed, in which case you become something else entirely. Pure energy, massless, experiencing no passage of time at all. This creates two distinct realms in our universe. The realm of matter where we live, where time passes and change occurs, and the realm of light, where photons exist in a timeless, massless state of pure energy. The barrier between these realms is absolute, like the ultimate cosmic border checkpoint that simply cannot be crossed by anyone carrying the passport of mass. Yet this barrier, while absolute, isn't a prison. It's more like a cosmic speed limit that keeps the universe functioning properly. Just as traffic lights help cars move safely through intersections, the light speed barrier helps causality flow properly through space-time. Without it, the universe might become a confusing place where effects precede causes and logic breaks down. In the quiet of your evening, countless particles around you are buzzing with energy, vibrating in atoms, flowing as electricity, radiating as heat, all of them held back by this fundamental speed limit. They dance right up to the edge of possibility, but can never quite reach that ultimate speed. It's like watching eternally hopeful dancers who can approach the perfect rhythm, but never quite achieve it. And perhaps that's beautiful in its own way. The speed of light stands as a reminder that even in a universe full of incredible possibilities, there are still some absolute boundaries, cosmic principles, so fundamental that they shape the very nature of existence itself. This barrier doesn't limit the universe. It defines it, giving structure and meaning to the dance of matter and energy across the cosmos. Time, that steady companion we've trusted since childhood to tick away in reliable, even steps, begins to act quite strangely when we start moving very, very fast. It's as if time itself becomes shy, slowing down its pace the faster we go, like a friend who walks more and more slowly as we rush towards some cosmic destination. Imagine you're holding a perfectly reliable pocket watch, the kind that keeps exact time down to the tiniest fraction of a second. Now imagine climbing aboard a spacecraft that can travel at tremendous speeds, perhaps 90% the speed of light. As your ship accelerates and you settle into this incredible velocity, something wonderful and weird begins to happen. Your pocket watch continues ticking at exactly the same pace it always has. From your perspective, you feel perfectly normal. Time seems perfectly normal. Everything aboard your ship continues in its familiar rhythm. But to someone watching from Earth, through an impossibly powerful telescope, your pocket watch has begun moving like it's stuck in thick honey. From their perspective, your seconds have stretched into their minutes. Your heartbeat, your breathing, even your thoughts. Everything about you has slowed down dramatically. Yet you, sitting comfortably in your speeding ship, notice absolutely nothing unusual. Time still feels like time to you. This isn't science fiction trickery or some elaborate illusion. This is how time actually behaves in our universe, revealed through Einstein's patient observations of how reality works at its deepest levels. Time isn't the unchanging river we once thought it was. It's more like a gentle stream that can speed up or slow down, depending on how fast you're moving through space. The mathematics behind this is surprisingly elegant. There's a simple equation that tells us exactly how much time will slow down at any given speed. At everyday speeds, walking, driving, even flying in the fastest jets, the effect is so tiny as to be virtually unnoticeable. But as you approach the speed of light, time dilation becomes more and more dramatic, like a curve that starts gently and then swoops upward more and more steeply. At 90% light speed, time slows to less than half its normal rate. At 99% light speed, it slows to about 1/7. And as you get closer and closer to light speed itself, time stretches thinner and thinner, like taffy being pulled by cosmic hands, until at exactly light speed, time would stop completely. Though as we've learned, nothing with mass can actually reach that point. This stretching of time isn't just theoretical anymore. We can measure it with atomic clocks, so precise they can detect the tiniest changes in time's flow. Scientists have flown these clocks on airplanes and found that they indeed run slightly slower than identical clocks left on the ground. Particles in accelerators experience such extreme time dilation that they live much longer than they should, from our perspective, before decaying. Even satellites orbiting Earth experience measurable time dilation. The GPS system in your phone has to account for this effect. The atomic clocks on GPS satellites run slightly faster than clocks on Earth's surface because they're moving quickly and experiencing less gravity. Without correcting for time dilation, your GPS would gradually become less and less accurate, eventually telling you that you're miles from where you actually are. But perhaps the most beautiful aspect of time dilation is how it preserves something precious, all the consistency of natural laws. From your perspective aboard that incredibly fast spacecraft, physics works exactly the way it always has. Light still travels at light speed. Your coffee still cools at the normal rate. Your book still takes the usual amount of time to read. The universe hasn't broken down or become chaotic. It has simply revealed that time itself is more flexible than we ever imagined. This flexibility of time hints at something profound about the nature of reality. Time isn't some external clock that the universe obeys. It's woven into the very fabric of space itself, part of a unified space-time that can stretch and bend and flow like a cosmic river. When we move very fast through space, we're actually changing our relationship with time itself, moving through the universe's fabric in a way that naturally, inevitably affects how we experience the flow of moments. In the stillness of your evening, time flows around you at its familiar pace. But knowing that this pace can change, that time itself can dance and stretch and slow, adds a layer of wonder to each passing second. Every tick of every clock is really a celebration of our particular motion through the cosmos, our steady journey through space-time, at speeds that keep time flowing in the gentle, reliable rhythm we've always known. Let me tell you a story about two people who loved each other dearly, perhaps twins, perhaps dear friends, perhaps simply two souls connected by the invisible threads that bind hearts across space and time. For our gentle tale tonight, let's call them Luna and Sol, and imagine them at the moment when their paths must diverge in the most extraordinary way. Luna, adventurous and bold, decides to journey to a distant star, not in some future century when such travel might be commonplace, but in our story, where physics bends kindly to allow her passage at tremendous speeds, let's say 95%, the speed of light. Sol, equally brave but in a different way, chooses to remain on Earth, to tend the gardens and watch the seasons turn, to be the anchor point for Luna's return. As Luna's ship accelerates away from Earth, something beautiful and strange begins to unfold. From Sol's perspective, watching through telescopes that can somehow see across the vast distances, Luna's life appears to slow down, like a film played in slow motion. Her movements become languid. Her heartbeat stretches out. Her very aging process crawls along at a fraction of its normal pace. Years pass on Earth. Sol grows older, hair perhaps silvering, lines etching gentle stories around the eyes, while Luna seems to remain suspended in time, aging only months for every year that passes on Earth. But here's the mystery that puzzled scientists for decades. From Luna's perspective, everything appears completely normal aboard her ship. Her coffee still steams, her heart beats its familiar rhythm, her thoughts flow at their usual pace. When she looks back toward Earth through her own instruments, it's Sol who appears to be moving in slow motion, Sol whose life seems to crawl along at a snail's pace. So which one is really aging more slowly? This question danced through the minds of physicists, like a riddle wrapped in an enigma, until they realized that the answer reveals something profound about the nature of journeys themselves. The key lies in understanding that this isn't truly a symmetrical situation, though it might appear to be at first glance. Luna must accelerate to reach her tremendous speed, then later decelerate and turn around to come home, then accelerate back toward Earth, and finally decelerate again to land safely. So, meanwhile, continues in steady motion, following Earth's gentle orbital dance around the Sun without any dramatic changes in velocity. These accelerations, the speeding up, slowing down and turning around, break the symmetry of the situation. During these periods of acceleration, Luna experiences something different from the steady motion she feels during the long coasting phase of her journey. It's during these accelerations that the universe reveals which of our two friends is truly moving in the deeper sense that matters for time dilation. When Luna finally returns home, the reunion is bittersweet and beautiful. She steps from her ship, having aged perhaps only a few years during her decades-long journey, while Sol has grown older in the way we all expect. Following Earth's steady progression through time, Luna returns to find a world where seasons have cycled many times, where gardens have grown and changed, where the steady passage of years has left its gentle marks on everything she left behind. This isn't science fiction. It's a real consequence of how time works in our universe. Astronauts on the International Space Station experience a tiny version of this effect, aging microseconds less than they would on Earth's surface. Particles in cosmic rays experience dramatic time dilation, allowing them to reach Earth's surface before they would normally decay. The profound beauty of this story lies not in the strangeness of the physics, but in what it reveals about the nature of choice and journey. When we choose to move through space at tremendous speeds, we also choose to move through time differently. We trade the shared rhythm of time with our loved ones for the gift of experiencing the cosmos from a radically different perspective. In Luna's case, she gains something precious, the ability to journey to distant stars and return while still young enough to share her discoveries. But she also gives up something equally precious, the ability to grow old alongside those she loves, to share each passing season, each quiet evening, each subtle change that comes with the steady passage of time. This trade-off speaks to something deeper about the choices we make in life. Every path we take, every speed at which we choose to live, shapes our experience of time in subtle ways. While we may not travel at 95% light speed, we all make choices about how quickly to move through our lives, how much to pack into our days, how to balance the desire for adventure with the peace of shared moments. The twin paradox reminds us that time isn't just something that happens to us. It's something we participate in, something shaped by our motion through the universe, something that connects us to the deepest mysteries of space and time themselves. As we venture closer and closer to the speed of light, something almost mystical begins to happen to time itself. It's as if we're approaching the shores of some timeless ocean, where the familiar waves of seconds and minutes gradually calm into perfect stillness. This journey toward light speed is like walking toward a horizon that reveals increasingly strange and beautiful landscapes with each step. Imagine accelerating gradually, gently, in that wonderful spacecraft of our imagination. At 50% light speed, time has slowed noticeably but still flows like a lazy river. Your earthbound friends might notice you aging about 15% more slowly than they are, significant, but not dramatically so. At 70% light speed, time slows more substantially like honey on a cold morning. At 90%, it flows at less than half its normal rate. But as you push higher, 95%, 99%, 99.9%, something extraordinary begins to happen. Time doesn't just slow down anymore. It begins to approach something like a complete stop. Each additional fraction of a percent closer to light speed requires enormous amounts of energy and produces ever more dramatic time dilation, like approaching the edge of a cosmic cliff where time itself might tumble into timelessness. At 99.9% light speed, time crawls along at roughly 2% of its normal rate. A single heartbeat might stretch across what would normally be a minute. A breath could span what feels like an hour to those watching from outside. And still, from your perspective inside this incredible journey, everything feels perfectly normal. Your heartbeat feels normal. Your breathing feels normal. Your thoughts flow at their familiar pace. This creates a strange and beautiful paradox. The closer you get to light speed, the more dramatically time slows from the outside perspective. Yet you yourself never notice any change. It's as if the universe is playing a gentle cosmic joke, allowing you to approach timelessness while keeping you completely unaware of the transformation happening around you. As we push even closer, 99.99% light speed, time dilation becomes so extreme that years might pass in the outside world while you experience what feels like minutes. You could journey to distant galaxies and return to find that civilizations have risen and fallen, that the stars themselves have changed, that the Earth has aged eons while you've barely noticed the passage of time. And yet, there's something profound and perhaps beautiful about this extreme slowing of time. In approaching light speed, you begin to participate in something like the eternal now that mystics and philosophers have written about for centuries. The past and future begin to compress into an increasingly thin slice of experienced time until you exist almost entirely in an extended present moment. But what happens at exactly light speed? Here, mathematics points us towards something truly extraordinary. Time stops completely, not slowed, not crawling, stopped. At light speed, there is no passage of time at all. Pat roll, stopped. At light speed, there is no passage of time at all. It's as if you would step outside the normal flow of temporal experience entirely, existing in a realm where all moments are one moment, where the entire journey from one star to another happens in a single eternal instant. Of course, as we've learned, nothing with mass can actually reach light speed. This timeless realm remains forever just beyond the reach of matter, like a mathematical horizon that can be approached but never quite touched. Only massless particles like photons can exist in this strange realm where time holds its breath. This has led some physicists and philosophers to wonder about the experience of light itself. If a photon could be said to have an experience, it would exist in this timeless state throughout its entire journey. A photon leaving a distant star and traveling for billions of years to reach your eye would, from its own perspective, experience that entire journey as a single instantaneous event. No time passes for the photon itself. It exists in an eternal present that encompasses its entire existence. There's something deeply moving about this idea. Light, which brings us information about the universe, which carries the warmth of stars and the beauty of rainbows, which makes vision and life itself possible, exists in a realm beyond time, as we understand it. Every beam of light is, in a sense, a messenger from eternity, carrying its information across space in a state of timeless being. As you settle into the quiet of your evening, surrounded by gentle light from various sources, you're in the presence of countless particles that exist in this timeless realm. They've journeyed from their sources to your eyes in what is, for them, no time at all, yet they've carried across space and time the gift of vision, the ability to see and appreciate the universe around you. The approach to light speed teaches us that time isn't the fixed, unchanging backdrop we once thought it was. Instead, it's a river with currents that can slow to an almost perfect stillness, a dimension of reality that becomes increasingly mystical as we approach the cosmic speed limit, where time itself dissolves into timelessness. When we embark on our journey toward light speed, something remarkable happens not just to time, but to space itself. The universe begins to act like it's made of some cosmic elastic material, stretching and compressing in ways that would seem impossible if we hadn't learned to trust the strange beauty of Einstein's insights. Space, it turns out, is far more flexible than our everyday experience suggests. Imagine you're looking out the front window of your spacecraft as you accelerate to tremendous speeds. At first, the view ahead looks much as you'd expect. Stars scattered across the black velvet of space, perhaps a distant planet or nebula catching your eye. But as your speed increases to significant fractions of light speed, something wonderfully strange begins to happen to the very geometry of the universe around you. The distance to objects ahead of you begins to shrink, not because you're getting closer in the ordinary sense, but because space itself is contracting along your direction of motion. It's as if the universe is gently squeezing itself, like an accordion being compressed, but only in the direction you're traveling. A journey that should take years at your incredible speed seems to require less and less time, not because you're going faster than you thought, but because there's literally less space to cross. This isn't an optical illusion or a trick of perspective. From your viewpoint, as a high-speed traveler, the universe has genuinely become shorter in the direction you're moving. A distant star that Earth-based astronomers measure as being 100 light-years away might appear to be only 50 light-years away from your perspective, or 20, or even less, depending on just how close to light speed you're traveling. The mathematical relationship is beautifully precise. The same equation that tells us how much time dilates also tells us how much space contracts. At 90% light speed, distances shrink to about 44% of their rest length. At 99% light speed, they compress to just 14%. The faster you go, the more the universe squeezes itself along your path, making even the vastest cosmic distances seem surprisingly manageable. But here's what makes this even more fascinating. This contraction only happens along the direction of your motion. If you look to the sides, up or down, space appears completely normal. The universe doesn't shrink uniformly. It compresses like a three-dimensional photograph being squeezed from one side. Stars to your left and right maintain their normal distances from each other, but the star directly ahead of you seems to be racing towards you faster than its light speed should allow, simply because there's less space between you and it than there should be. This creates a peculiar geometry where the universe becomes increasingly flat and compressed as you approach light speed. Imagine a sphere slowly being pressed into a pancake. That's somewhat like what happens to your perception of cosmic distances. The rich, three-dimensional tapestry of space begins to collapse into something more like a thin sheet, with most of the universe's volume squeezed into increasingly thin slices perpendicular to your direction of travel. From the perspective of Earth, watching your journey, something equally strange is happening. They see your spacecraft itself, contracting along its direction of motion, becoming flatter and flatter like a cosmic playing card. Yet inside your ship, everything appears perfectly normal to you. Your morning coffee cup is still round, your books are still their normal thickness, your cabin still has its familiar proportions. The contraction only appears when comparing your reference frame to someone else's. This reciprocal nature of length contraction mirrors what we saw with time dilation. Just as you see time moving slowly in the stationary universe, while feeling your own time flow normally, you see space contracted in the direction of your motion, while experiencing your own spatial environment as perfectly normal. It's as if the universe has a sense of fairness. Everyone gets to feel normal in their own reference frame, while noticing the strangeness only in others. The practical implications of this are profound for cosmic travel. A journey to the center of our galaxy, normally about 26,000 light-years away, could appear much shorter to a traveler moving at very high speeds. The universe itself provides a kind of cosmic shortcut by compressing the distances that need to be traveled. It's nature's way of making the seemingly impossible journeys of science fiction at least theoretically possible. Yet this spatial compression carries with it a poetic beauty. The universe reveals itself to be not a rigid stage on which events unfold, but a dynamic, responsive medium that adapts to the motion of everything within it. Space and time, woven together into the fabric. Einstein called space-time, flow and bend and stretch in ways that accommodate even the most extreme journeys, while preserving the fundamental consistency of physical laws. As you rest in your earthbound evening, the space around you maintains its familiar dimensions, its comfortable geometry, where up is up and forward leads steadily forward. But knowing that this space can compress and stretch, that the universe itself is far more flexible and accommodating than it appears, adds a layer of wonder to the simple act of existing within the cosmic fabric that surrounds us all. As we push our imaginary journey even closer to the speed of light, the compression of space becomes so extreme that the universe begins to resemble something almost impossible to visualize, a reality that has been flattened like an infinitely thin sheet of cosmic paper. This isn't just a gradual squeezing anymore, it's a transformation so dramatic that it challenges our very ability to picture what existence might look like in such a realm. Picture yourself now traveling at 99.9%, the speed of light, a speed so close to the cosmic limit that the difference has become almost meaningless. Samid se vor law. From your perspective, looking ahead toward your destination, the entire universe in that direction has compressed to a thickness that might be measured in meters rather than light years. Entire solar systems, with their vast spaces between planets, have been squeezed into regions so thin that you could almost reach out and touch what were once distant worlds. The galaxy ahead of you, perhaps the Andromeda Galaxy, with its billions of stars spread across hundreds of thousands of light years, now appears as flat as a photograph pressed between the pages of a cosmic book. All of those stars, all of that space, all of those vast distances that represent journey times of millions of years at ordinary speeds, have been compressed into a layer so thin that it barely seems to have depth at all. Yet this isn't science fiction magic or some violation of physics. This is space itself responding to your motion in exactly the way Einstein's equations predict. The universe hasn't broken down or become impossible. It has simply revealed another of its profound and beautiful symmetries. Just as time can stretch and slow, space can compress and flatten, all while maintaining the underlying consistency that keeps reality functioning properly. From your cabin window, looking to the sides, you still see a universe of normal depth and dimension. Stars twinkle at their expected distances, nebulae maintain their billowy three-dimensional structure, and space continues to have the familiar geometry you've always known. But ahead and behind you, along your line of motion, the universe has become almost one-dimensional, like looking at the edge of an incredibly thin cosmic blade. This flattening creates an almost mystical view of reality. Imagine seeing the entire history and future of your journey compressed into a single paper-thin slice. Your departure point behind you and your destination ahead exist in regions so flattened that they seem to occupy almost the same plane of existence, separated by distances that have become nearly meaningless in the ordinary sense. What makes this even more extraordinary is how this flattening affects your relationship with cosmic time and space. That distant galaxy, which should take millions of years to reach even at your incredible speed, now lies in a region so compressed that the journey might subjectively take only months or even weeks. The universe has provided its own form of cosmic magic carpet, allowing you to traverse distances that should be prohibitive by simply reducing the amount of space that needs to be crossed. But perhaps the most mind-bending aspect of this flattened reality is how it affects causality and events. In this compressed universe, events that are separated by vast distances along your line of motion begin to seem almost simultaneous. The birth of a star in one galaxy and the death of another in a distant galaxy both occur within your flattened field of view, appearing to happen within the same thin slice of compressed space-time. The mathematics behind this flattening becomes increasingly extreme as you approach light speed itself. At exactly light speed, that impossible realm where only massless particles can exist, the compression becomes infinite. Space contracts to zero thickness along the direction of motion. The entire universe, from the perspective of a photon, exists as a single, infinitely thin plane with no depth whatsoever in the direction of travel. This creates a strange and beautiful picture of how photons might experience their journey across the cosmos. Every beam of light that reaches your eye right now has, from its own perspective, traveled across a universe that was compressed to zero thickness. The light from distant stars didn't cross vast spaces, so much as it existed in a realm where those vast spaces had been squeezed out of existence entirely. There's something deeply poetic about this vision of reality, or the universe reveals itself to be, not just vast and magnificent in its ordinary three-dimensional glory, but also capable of compressing itself into forms so exotic that they stretch our imagination to its limits. There's something deeply poetic about this vision of reality. Space itself becomes a kind of cosmic accordion, capable of expanding into the vast reaches we see around us on quiet nights, or compressing into the paper-thin slices that exist for travelers approaching light speed. This flattening of reality also speaks to the deep interconnectedness of space and time. As space compresses along your direction of motion, time dilates in perfect proportion, ensuring that the laws of physics remain consistent even in these extreme circumstances. The universe seems to have built-in safeguards that prevent any contradiction or paradox from arising, even when reality itself has been squeezed into these almost unimaginable configurations. In the three-dimensional comfort of your evening space, surrounded by the familiar geometry of walls and furniture, rooms and distances, it's worth marveling at how malleable reality truly is, how space itself can bend and compress and flatten, while still maintaining the mathematical elegance that keeps existence both possible and beautiful. In the quiet elegance of Einstein's mathematics, we discover that space and time aren't separate things at all, but rather two aspects of a single, unified fabric called space-time. As we journey toward light speed, this fabric reveals its most beautiful and mysterious properties, showing us how the geometry of reality itself depends on motion, speed, and perspective in ways that transform our understanding of existence itself. Think of space-time as a vast, invisible tapestry woven through everything around you right now. As you sit reading these words, you're not just occupying a position in space, you're also occupying a position in time, and these two coordinates together define your location in this four-dimensional fabric. Every object, every particle, every beam of light exists somewhere within this grand tapestry, following paths through space-time that we call world lines. When you're at rest, or moving at everyday speeds, your world line through space-time is fairly straightforward. You move primarily through time, advancing second by second into the future, with only small movements through space. But as you begin to move faster and faster, something beautiful happens to your path through space-time. You begin to trade motion through time for motion through space in a cosmic exchange that maintains perfect mathematical balance. Imagine space-time as having a kind of speed limit for all motion combined, motion through space plus motion through time. When you're sitting still, all of your motion budget is spent moving through time at the maximum rate. But as you begin to move through space, some of that budget gets redirected from time motion to space motion. The faster you move through space, the slower you move through time, and vice versa, like a cosmic conservation law that ensures the total always remains constant. This is why time dilation and length contraction occur together, in perfect mathematical harmony. As you approach light speed, trading more and more of your time motion for space motion, several things happen simultaneously. Time slows down from outside perspectives. Distances contract along your direction of motion, and your energy requirements increase dramatically. These aren't separate phenomena. They're different aspects of the same underlying geometric reality. The mathematics reveals something even more beautiful. There's a fundamental relationship between how much time dilates and how much space contracts. They're linked by the same mathematical factor, ensuring that the speed of light remains constant regardless of your motion. This isn't just a coincidence, it's a deep geometric necessity that preserves the structure of causality itself. Picture the geometry this way. As you move faster through space, your slice of simultaneous events, what you consider to be now throughout the universe, becomes tilted relative to someone at rest. Your now and their now no longer align perfectly, creating a situation where events that seem simultaneous to you occur at different times from their perspective, and vice versa. Yet somehow, despite this shifting of simultaneity, the fundamental laws of physics remain the same for everyone. This geometric dance becomes increasingly dramatic as speeds approach light itself. Near light speed, your path through space-time becomes so tilted that your journey through space almost completely dominates your motion through time. You're still moving through the same four-dimensional fabric, but your path has become so different from that of slower-moving observers that you experience reality in an almost completely transformed way. At exactly light speed, that mathematical limit where only massless particles can travel, the geometry becomes perfectly tilted. Photons follow paths through space-time that are purely spatial from their perspective, with no motion through time at all. They exist in a geometric realm where all of space-time has been rotated into a configuration we can barely imagine, where the journey from one galaxy to another occupies zero time and zero space simultaneously. This geometric understanding helps explain why the speed of light is so fundamental to the structure of reality. It's not just a speed limit, it's the geometric constant that defines the relationship between space and time themselves. The speed of light is, in essence, the conversion factor between space and time, the cosmic exchange rate that determines how motion through one dimension trades off against motion through the other. The beautiful consequence of this geometric view is that it reveals the deep unity underlying seemingly separate phenomena: time dilation, length contraction, mass-energy equivalence, the constancy of light speed. All of these emerge naturally from the geometry of space-time itself. They're not separate laws, but different facets of a single, elegant, geometric reality. Even more remarkably, this geometry remains consistent regardless of perspective. While different observers may disagree about measurements of time and space, they all agree on the underlying geometric relationships. The fabric of space-time provides a kind of cosmic democracy where everyone's perspective is equally valid, yet everyone agrees on the fundamental structure of reality itself. As you rest in your familiar three-dimensional space, it's wondrous to consider that you're actually moving through a four-dimensional geometric structure at tremendous speed, roughly 300,000 kilometers per second through time. Every moment of your existence traces a path through space-time's invisible geometry, participating in the same cosmic dance that governs everything from orbiting electrons to distant galaxies, all following the elegant mathematical choreography that Einstein revealed to be the true nature of space, time, and speed itself. Close your eyes for a moment and imagine something impossible yet beautiful. Imagine you could somehow transform yourself into pure light, shedding the burden of mass and becoming a photon racing through the cosmos at that ultimate speed we've been approaching but could never quite reach. What would it feel like to ride a beam of light across the universe, to experience reality from the perspective of light itself? The journey begins the moment you're born, perhaps in the heart of a distant star where nuclear fusion has created you from the marriage of energy and possibility. In that instant of creation, you begin moving at exactly the speed of light, not accelerating up to it gradually, like our imaginary spacecraft, but simply existing at that speed from the very first moment of your existence. There's no sensation of acceleration, because there was no time when you weren't already traveling at light speed. From your perspective as a photon, something extraordinary happens to the universe around you. Remember how space contracted more and more dramatically as our massive spacecraft approached light speed. For you, traveling exactly at light speed, that contraction becomes infinite. The entire universe in your direction of travel compresses to zero thickness. The vast cosmic distances that seem so imposing to matter-bound observers simply don't exist from your perspective. A journey across billions of light-years becomes, geometrically speaking, no journey at all. But this is only part of the miracle of your photon existence. Not only has space compressed to nothingness in your direction of travel, but time itself has stopped completely. You exist in a realm where there is no before or after, no sequence of events, no passage of moments. Everything that happens during your journey, from the moment you leave your stellar birthplace to the instant you arrive at your destination, occurs in a single eternal now. Imagine the profound strangeness of this existence. You might be traveling from a star in the Andromeda galaxy to Earth, a journey that observers measure as taking over 2 million years. Entire civilizations might rise and fall during your travel time. Mountain ranges could form and erode away, continents could drift across planetary surfaces. Yet for you, all of this happens instantaneously, compressed into a single moment that contains no duration whatsoever. With your photon perspective reveals something beautiful about the nature of information and connection across the cosmos. Every beam of light is in essence a direct, instantaneous connection between its source and destination. When you as a photon carry information about the star that created you, its temperature, its chemical composition, its motion through space, you deliver that information across vast distances in what is, from your perspective, no time at all. This creates a strange and wonderful picture of cosmic communication. The universe is constantly filled with these instantaneous connections, these zero-time bridges spanning enormous distances. The light that left the sun 8 minutes ago and is now striking your skin represents an instantaneous connection between you and our nearest star, mediated by photons that experience no passage of time during their journey. But perhaps most remarkable is how your photon existence challenges our usual notions of experience and consciousness. Can you, as a massless packet of energy, be said to have experiences at all? If you could somehow be aware during your light-speed journey, what would that awareness be like? Would it be a kind of cosmic meditation, existing in an eternal present with no past to remember or future to anticipate? From your photon perspective, causality itself takes on a different meaning. Effects don't follow causes in time, because there is no time. They simply exist in perfect, simultaneous relationship. The star that birthed you and the eye that eventually absorbs you exist in the same eternal moment, connected by your timeless journey across space that has been compressed to nothing. This photon's eye view also reveals something profound about the relationship between matter and energy. Whole, you exist as pure energy, unencumbered by mass, free to travel at the ultimate cosmic speed. Yet you carry within your electromagnetic oscillations all the information needed to tell matter about the distant places you visited. You're like a cosmic messenger who can travel instantaneously between any 2 points in the universe, carrying news from one realm of matter to another. Your existence as a photon also demonstrates the ultimate democracy of light speed. Whether you were born in the gentle glow of a candle flame or the violent explosion of a supernova, whether you carry the red light of a cool star or the blue light of a hot one, whether you travel across your bedroom or across the observable universe, you always move at exactly the same speed, always experience the same timeless existence, always participate in the same geometric relationship with space-time. And when your journey ends, when you strike a retina, a solar panel, or simply a dust grain floating in space, you vanish instantly, your energy absorbed and transformed, your timeless existence ending as abruptly as it began. In that moment of absorption, the information you've carried across the cosmos finally enters the world of matter and time, while your instantaneous journey becoming part of the slower, more measured pace of massive existence. Hodia's wants and time see, Hodia's pay, Ummiya. Tonight, as countless photons stream through the darkness around you, each one is completing its own timeless journey, its own instantaneous connection between distant sources and your immediate surroundings, weaving the universe together with threads of light that exist outside of time itself. In the realm of light, there exists something that challenges our deepest intuitions about existence itself, the eternal moment. For a photon, every journey, whether it lasts microseconds or millions of years from an outside perspective, occurs within a single unextended instant that somehow contains everything and nothing, duration and timelessness, beginning and end all compressed into one perfect eternal now. Try to imagine what this eternal moment might contain. Picture a photon born in the nuclear furnace of a star billions of years ago, carrying within its electromagnetic essence the story of stellar fusion, the signature of elements forged in cosmic fire. From our perspective, this photon has been traveling for eons, crossing vast emptiness, perhaps bending around massive objects, witnessing the birth and death of worlds. Yet for the photon itself, all of this happens in an instant that has no beginning, no middle, no end. This isn't simply an instant in the way we usually think of instants, those tiny slices of time between one moment and the next. This is something far more profound, a moment that exists outside the flow of time entirely, and now that encompasses what we would measure as entire epochs. It's as if the photon exists in a bubble where all of time has been compressed into a single point, where past and future lose their meaning and collapse into pure presence. Consider what this means for the photon's journey across the universe, as it travels from its stellar birthplace toward perhaps your eye. As you read these words, it doesn't experience the gradual crossing of space that we observe. Instead, its departure and arrival exist in the same eternal moment. The star that created it and the retina that will absorb it are not separated by time from the photon's perspective. They are simply different aspects of the same timeless event. This eternal moment contains something like perfect knowledge. The photon doesn't discover its destination gradually as it travels in its timeless perspective. The destination has always been part of its existence, woven into the same eternal instant as its creation. It's as if the entire journey exists as a completed thought in the mind of the universe, with beginning and end present simultaneously in the photon's timeless awareness. But what kind of existence can this be? We, trapped in our temporal experience, can barely imagine consciousness without the flow of time. We think in sequences, first this thought, then that one. We experience, first this sensation, then that one. We remember, first this event happened, then that one. But for a photon existing in the eternal moment, none of these familiar frameworks apply. Perhaps the photon's existence is something like pure being without becoming, existence without change, knowledge without learning. It doesn't grow or develop or accumulate experience over time, because there is no time. Instead, it simply is, completely and perfectly, from the first instant of its existence to the last, all contained within that single eternal moment. This timeless existence might be the closest thing in the physical universe to what mystics and philosophers have called eternity. Not endless time, but the complete absence of time. The photon exists in a realm where duration has been replaced by something else entirely, something we can describe mathematically but can barely imagine experientially. From this perspective, every beam of light becomes a bridge between the temporal world where we live and this eternal realm where photons exist. When sunlight touches your skin, you're feeling the end result of a journey that, from the photon's perspective, occurred in an eternal instant, spanning the 150 million kilometers between Earth and Sun. The warmth you feel is the temporal manifestation of something that exists outside of time. This eternal moment also reveals something beautiful about the nature of cosmic connection. In the photon's timeless perspective, all the places it touches during its journey exist simultaneously. The star that birthed it, every dust grain it passes, every planet it illuminates, and ultimately the destination where it's absorbed, all of these exist together in the same eternal moment, connected by the photon's timeless presence. Perhaps most remarkably, this means that the universe is constantly filled with these eternal moments, these bridges between time and timelessness. Every point of light in the night sky represents countless photons carrying their eternal moments across space, each one existing in its own perfect, timeless bubble while simultaneously connecting the temporal world to the realm beyond time. The eternal moment of light also suggests something profound about the nature of information and communication in the universe. When we receive light from distant stars, we're not just receiving information that has traveled through time. We're receiving information from these eternal moments, timeless messages that exist simultaneously at their source and destination. As you rest in your evening quiet, surrounded by gentle light from various sources, you're in the presence of countless eternal moments. Each photon reaching your eyes carries within itself this perfect, timeless existence, this bridge between the flowing time you experience and the eternal now that lies at the heart of light itself. In some strange and beautiful way, every moment of illumination connects you to eternity, allowing you to touch, however briefly, the timeless realm where light dwells in its eternal, perfect presence. From the perspective of light itself, the universe reveals one of its most profound and mysterious aspects, the collapse of all space and time into a single, unified experience, where everything and everywhere and everywhen become meaningless distinctions. For a photon, the entire cosmos exists as one seamless, timeless, spaceless moment, a view so radically different from our own that it challenges our very concepts of existence and awareness. Imagine, if you can, being a photon of light that began its journey in the heart of a star at the edge of the observable universe. From our earthbound perspective, this represents an almost incomprehensible journey, billions of light years across space, billions of years through time, traveling through expanding cosmic voids, past countless galaxies, through clouds of interstellar dust, around the gravitational influences of massive objects, finally arriving here to this moment where it might strike your eye as you gaze up at a distant star. But from the photon's perspective, this entire epic journey, this vast cosmic odyssey that spans eons and encompasses distances so large, they strain human imagination, occurs as a single indivisible event. The birth of the photon in stellar fusion and its absorption in your retina don't happen at different times, separated by billions of years. They happen in the same eternal instant, as though the universe has folded itself so completely that beginning and end touch each other in timeless unity. This means that for light, the entire observable universe exists as a single point of experience. Every galaxy the photon passes, every star it encounters, every planet it illuminates along its journey, all of these exist simultaneously in the photon's eternal moment. Distance becomes meaningless because space has contracted to zero thickness. Duration becomes meaningless because time has stopped completely. What remains is something we can barely conceive, a form of existence where everything that ever was, is, or will be along the photon's path exists as one unified whole. In this view, the photon doesn't travel through the universe so much as it contains the universe within its timeless existence. Every point along its journey exists simultaneously within its eternal moment. The star that birthed it billions of years ago and the destination it will reach billions of years from now are not separate events connected by travel. They are aspects of the same seamless, timeless experience. This photon's eye view suggests something remarkable about the nature of cosmic interconnection. If we could somehow access this light-speed perspective, we might see that the universe isn't really a collection of separate objects scattered across vast distances and times. Instead, it might reveal itself as a single unified whole, where every part is instantly and eternally connected to every other part through the timeless perspective of light. Consider what this means for our understanding of cosmic communication and connection. Every beam of light, connecting any 2 points in the universe, creates this kind of eternal, instantaneous bridge. The light traveling between distant galaxies doesn't just carry information across space and time. From its own perspective, it unifies those distant regions into a single, timeless experience. The universe is constantly creating these eternal connections, these bridges of light that exist outside of space and time, while simultaneously spanning both. This unified perspective also reveals something profound about the nature of observation and knowledge. When light carries information about distant stars to our telescopes, it's not just delivering data that has traveled across space. From the light's perspective, the star being observed and the telescope doing the observing exist in the same eternal moment. The observation isn't separated from what's being observed by time or distance. They're unified in the timeless experience of the light that connects them. But perhaps most remarkably, this light-speed perspective suggests that consciousness and awareness might have aspects we've never considered. While we don't typically think of photons as being conscious, their existence demonstrates a form of knowing or being present that encompasses everything along their path simultaneously. They exist in perfect, immediate relationship with every point they connect, experiencing, if we can use that word, the universe as a unified whole rather than a collection of separate parts. This raises profound questions about the nature of awareness itself. Our human consciousness is thoroughly temporal. We experience one moment after another, remember the past, anticipate the future. But the photon's existence suggests a completely different kind of presence, simultaneous awareness of everything within its eternal moment, a form of knowing that encompasses beginning and end, source and destination, journey and arrival all at once. As photons stream around you right now, from your reading light, from the stars outside, from every illuminated surface, each one carries within its existence this unified view of reality. They connect you instantaneously to their sources, creating eternal bridges that span what we perceive as vast distances and times. In their timeless perspective, you and the distant stars exist in the same eternal moment, unified by the light that connects you across the apparent separations of space and time. In some beautiful and mysterious way, the light-speed perspective reveals that beneath the flowing temporal world we inhabit lies a deeper reality where everything is connected, where all separation is illusion, where the entire universe exists as one eternal, unified, timeless whole, witnessed by the light that fills every corner of existence. Light, that most faithful cosmic messenger, carries within its electromagnetic waves not just illumination, but also the secrets of motion itself. When light travels between objects that are moving relative to each other, something beautiful and revealing happens. The light changes color, shifting its hue in ways that tell stories about speed, direction, and the dance of cosmic motion that surrounds us everywhere. Imagine standing beside a railroad track as a train approaches, its whistle blowing. You've probably noticed how the pitch of that whistle changes, higher as the train approaches, lower as it recedes. This is the Doppler effect, named after the Austrian physicist who first described it. And it happens because the motion of the train compresses sound waves as it approaches and stretches them as it moves away. Light behaves in exactly the same way, though the effects are usually too subtle for our eyes to detect in everyday situations. But when objects move at tremendous speeds, significant fractions of light speed, the Doppler effect for light becomes dramatic and beautiful. Light waves get compressed or stretched, just like those train whistle sound waves. But instead of changing pitch, light changes color. Compressed light waves become bluer, stretched waves become redder, creating a cosmic rainbow effect that reveals the hidden motions of the universe. Picture yourself once again in that spacecraft, approaching light speed, watching the universe transform around you. As you accelerate toward distant stars, something magical begins to happen to their light. The photons streaming toward you from stars ahead don't just reach you faster, they arrive with compressed wavelengths. Their electromagnetic oscillations, squeezed together by your relative motion. Blue stars become brilliant white, white stars shift toward blue, and even red stars begin to take on a blue-white tinge. This isn't simply an optical illusion or a trick of perception. The light is genuinely changing color from your perspective, its wavelength physically compressed by the relative motion between you and its source. Each photon carries more energy than it would if you were at rest, packed into shorter wavelengths that shift the entire spectrum toward the blue end of the rainbow. But the effect goes far beyond simple color changes. As your speed increases towards significant fractions of light speed, the compression becomes more and more dramatic. Infrared light, invisible heat radiation that you normally couldn't see, gets compressed into visible red light. Radio waves from cosmic sources get squeezed into visible light. The entire electromagnetic spectrum shifts upward in frequency, revealing radiation that was previously hidden from view. At extreme speeds approaching light itself, this Doppler shift becomes almost surreal. Stars that normally emit gentle red light might appear as brilliant blue-white beacons. Radio galaxies that usually broadcast only in long radio wavelengths might suddenly become visible to the naked eye, their radio emissions compressed into visible light. The universe ahead of you transforms into a more energetic, more brilliant version of itself, painted in colors that reveal the hidden high-energy radiation normally invisible to human eyes. This shifting of light also works in reverse, though the effects are different in each direction. Just as sound from an approaching train has a higher pitch, while sound from a receding train has a lower pitch. Light from sources you're approaching gets blue shifted, while light from sources you're moving away from gets red shifted. Your motion through space creates a kind of cosmic rainbow gradient, with blue shifted light ahead and red shifted light behind. The mathematics of this color shifting is elegantly precise. The amount of shift depends exactly on your speed and the angle at which you're approaching or receding from the light source. Light from sources directly ahead experiences maximum blue shift, while light from sources directly behind experiences maximum red shift. Light from sources to the side experiences less shift, creating a complex pattern of color changes that surrounds you like a sphere of shifted light. This Doppler shifting of light isn't just a curiosity. It's one of the primary tools astronomers use to understand cosmic motion. When we observe that light from distant galaxies is red shifted, we know those galaxies are moving away from us. The amount of red shift tells us how fast they're receding, leading to our understanding that the universe itself is expanding. Every red-shifted photon is a messenger, carrying news about the cosmic expansion that began with the Big Bang. Even in our everyday world, Doppler shifts in light occur constantly, though they're usually far too small for our eyes to detect. Every time you drive toward a streetlight, its light becomes infinitesimally blue-shifted. Every time you move away from it, the light becomes infinitesimally red-shifted. Police radar guns work by detecting Doppler shifts in radio waves reflected from moving vehicles. The GPS satellites orbiting Earth must account for Doppler shifts in their signals to maintain accurate positioning. As you sit in your evening quiet, bathed in light from various sources, countless photons around you carry within their wavelengths the stories of motion and speed. The light from your reading lamp carries no significant Doppler shift, because you're both at rest relative to each other. This gerentithera Uria Suri. There's your ways of fauve, but starlight, streaming through your window, carries subtle shifts that tell of the Earth's orbital motion, the sun's journey through the galaxy, and the galaxy's own motion through space. Each photon, a tiny rainbow messenger, revealing the hidden dance of cosmic motion that surrounds us always. As you journey toward light speed, the direction of your travel becomes a window into something almost mystical, a blue-shifted future where the universe ahead transforms into a brilliant high-energy beacon that seems to compress all the light of distant cosmos into an increasingly intense, increasingly blue cone of illumination, stretching out before your spacecraft. Imagine looking through the forward windows of your light-speed vessel as you approach 90, then 95, then 99% of light speed. What began as subtle color shifts becomes a dramatic transformation of the entire forward view. Stars that were once red giants now shine with white-hot intensity. White stars blaze with brilliant blue fire, and stars that were already blue become almost too bright to look at directly, their light compressed into the high-energy blue and violet end of the spectrum. But the transformation goes far beyond what was originally visible. You remember that the electromagnetic spectrum extends far beyond the narrow band our eyes can see. As your speed increases, infrared radiation from warm objects gets compressed into visible red light. Microwave radiation gets squeezed into infrared. Radio waves from distant galaxies get blue shifted all the way up into visible light, suddenly making radio sources appear as visible stars in your forward view. This creates an extraordinary phenomenon. The universe ahead becomes not just bluer, but more visible, more energetic, more intense. Regions of space that appeared dark and empty at rest now glow with compressed radiation. Cool, dim objects become warm and bright. The entire electromagnetic symphony of the cosmos gets compressed into higher frequencies, revealing a universe that pulses with energy you never knew existed. As you push closer to light speed itself, this blue shifting becomes extreme beyond imagination. Rays from distant quasars get compressed into visible light. Gamma rays from cosmic explosions shift into the X-ray range, then into ultraviolet, then into visible blue. The universe ahead becomes a blazing cone of high-energy radiation, as if you're flying toward the cosmic equivalent of a searchlight that contains all the energy of countless stars and galaxies. But perhaps most remarkably, This blue shifting creates a kind of cosmic time machine effect. Light that left distant objects billions of years ago, light that has been traveling toward you across cosmic time, gets compressed and intensified as you race toward it. You're essentially flying into the universe's past, but experiencing it as a blue-shifted, intensified present. Ancient light becomes immediate, brilliant, overwhelming in its compressed intensity. The geometry of this blue shifting creates what physicists call a headlight effect. Just as the headlights of a moving car seem to create a cone of light pointing in the direction of travel, your motion through space creates a cone of blue-shifted, intensified light pointing in your direction of travel. Most of the light that was once spread evenly around you becomes concentrated into this forward cone, making the universe ahead blindingly bright, while the universe behind fades into red-shifted dimness. At extreme speeds, this headlight effect becomes so pronounced that virtually all the light you can detect comes from directly ahead. The stars and galaxies to your side seem to fade away, not because they've stopped shining, but because their light has been Doppler shifted out of the visible range, or has become too dim to detect. Your entire universe of visible light becomes concentrated into an increasingly narrow cone directly ahead of your spacecraft. This creates an almost surreal flying experience. Instead of seeing stars scattered across the sky in all directions, you see most of the universe's light compressed into a brilliant blue-white beacon straight ahead. It's as if you're flying toward a cosmic lighthouse that contains the compressed light of billions of galaxies, all blue-shifted into a single overwhelming source of illumination. The energy concentration in this blue-shifted cone becomes enormous at extreme speeds. Light that was once spread across the entire sky gets compressed into a narrow forward beam, creating an intensity that could be dangerous to any spacecraft traveling at such speeds. The same Doppler effect that creates the beautiful blue shifting also concentrates vast amounts of electromagnetic energy into your direction of travel. But there's something almost spiritual about this blue-shifted future. You're not just moving toward distant destinations, you're moving toward light itself, toward the compressed essence of electromagnetic radiation that fills the universe. The blue-shifted cone ahead represents all the light that was already traveling toward your destination, now compressed and intensified by your motion through space. This blue shifting also reveals something profound about the nature of cosmic exploration. When we journey toward distant stars at extreme speeds, we're not just crossing space, we're entering regions where the electromagnetic environment itself has been transformed by our motion. We're creating new relationships between ourselves and the light that fills the universe, new ways of experiencing the radiant energy that connects all things. As you rest in your familiar surroundings tonight, the light around you maintains its natural colors, its familiar spectrum from red to violet. But imagining this blue-shifted future, this brilliant cone of compressed cosmic radiation that would greet any traveler approaching light speed, adds a layer of wonder to every beam of light. Each photon carries within it the potential for this transformation, this compression into blue brilliance that reveals the hidden energy density of the electromagnetic universe that surrounds us always. While the universe ahead blazes with blue-shifted brilliance, something equally remarkable and poignant happens behind you as you journey toward light speed. The cosmos in your wake undergoes its own transformation, gradually fading into deeper and deeper shades of red, as if you're leaving behind a universe painted in sunset colors that grow ever more mellow and dim with each increase in your velocity. Turn around in your imaginary spacecraft and look back toward the direction you came from. What you see is the mirror image of the blue-shifted future, a red-shifted past where light waves have been stretched by your motion, their wavelengths elongated, their energies reduced, their colors shifted toward the warm, long wavelengths at the red end of the electromagnetic spectrum. The effect begins subtly, just as it did in the forward direction. Blue stars behind you begin to appear white. White stars take on a yellowish tinge, yellow stars shift toward orange, and red stars deepen into an even richer crimson. But as your speed increases towards significant fractions of light speed, this red shifting becomes more and more dramatic, creating a view behind you that seems painted in the colors of eternal sunset. One trail would come summers per and the sea, of you amive to invol. But unlike a terrestrial sunset, this cosmic red shifting doesn't stop at deep red. As your velocity approaches light speed, visible light from sources behind you gets stretched beyond the red end of the visible spectrum entirely, disappearing into infrared radiation that your eyes cannot see. The universe behind you begins to fade, not just because it's becoming redder, but because its light is being shifted beyond your ability to perceive it. This creates a strange and melancholy beauty. Stars that once shone brightly in blue and white now glow with the deep red warmth of dying embers. Galaxies that blazed with the light of billions of stars fade into dim, red patches that barely register against the darkness. It's as if you're watching the universe age and cool in fast forward, seeing stars transform from bright beacons into the fading remnants of ancient light. Into listy, 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 into listy. At extreme speeds, this red shifting becomes so severe that most of the visible universe behind you simply vanishes from sight. Blue and white stars redshift their way through orange and red and into infrared oblivion. Only the brightest, most energetic sources, perhaps X-ray binaries or gamma-ray bursts, maintain enough energy to remain visible after being redshifted down into the visible spectrum. The mathematics of this red shifting reveals something profound about the relationship between motion and perception. As you move faster and faster away from light sources, you're not just changing their apparent color, you're changing the very nature of the electromagnetic radiation you can detect from them. Radio waves get stretched into even longer radio waves. Infrared light gets stretched beyond detection. Visible light fades into infrared, then into radio waves so long they become undetectable by any reasonable instrument. This creates what astronomers call a dimming effect that goes beyond simple red shifting. Not only do sources behind you become redder, they also become dimmer because each photon carries less energy after being redshifted to longer wavelengths. A star that was blindingly bright might fade to barely visible as its high-energy blue photons get stretched into low-energy red ones, then into invisible infrared radiation. Perhaps most poetically, this red-shifted past creates the impression that you're outrunning light itself. While this isn't literally true, you can never actually overtake light. The visual effect is striking. Light that was once bright enough to illuminate your surroundings fades into deep red shadows, then into invisible infrared, creating the illusion that you're racing ahead of illumination itself, leaving behind a universe that grows darker and redder in your wake. This red-shifted rearview also reveals something about the nature of cosmic time and distance. The light you see behind you left those sources at various times in the past, depending on their distance. As you redshift this ancient light, you're essentially watching the universe's past grow dimmer and redder, as if you're traveling not just through space, but away from time itself, leaving history to fade into increasingly deep shades of red. The effect creates a natural asymmetry in your cosmic view. Ahead lies a brilliant blue-white cone of compressed, intensified light, the blue-shifted future that seems to concentrate the universe's energy into your direction of travel. Behind lies an increasingly dim red glow that fades toward darkness, the red-shifted past that seems to cool and darken as you leave it behind. You exist at the boundary between these two realms, between the brilliant future you're racing toward and the fading past you're leaving behind. This red-shifted rearview also serves as a poignant reminder of the connections you're leaving behind. If Earth lay in the direction behind you, its light would gradually redshift and dim, the blue marble of home eventually fading to a deep red point, then to invisible infrared, finally disappearing entirely from your ability to perceive it. You would be leaving not just the physical location of home, but even the light that connects you to it, watching that connection stretch and fade until it passes beyond the reach of sight itself. As you sit quietly tonight, surrounded by familiar light sources, consider this red-shifted perspective. Behind every photon streaming through your space lies the potential for this transformation, this gentle fading into red-shifted memory that would mark your passage through the cosmos at light speed, leaving behind a wake of sunset-colored light, gradually fading into the infrared darkness of outrun illumination. In the realm of everyday experience, we think of mass as something fixed and unchanging. Your coffee cup has the same mass whether it's sitting still on the table or flying through the air. A baseball has the same mass whether it's resting in your palm or speeding toward home plate. But as we venture into the extreme realm, approaching light speed, even this most fundamental property of matter begins to behave in ways that challenge our intuitive understanding of reality itself. Einstein's profound insight revealed that mass and energy are intimately connected, not just mathematically, but physically, in ways that become dramatically apparent as objects approach the cosmic speed limit. While the mass of an object, what physicists call its rest mass, remains constant, something called its relativistic mass increases with velocity, growing larger and larger as speed approaches that ultimate barrier of light itself. Imagine once again climbing aboard your spacecraft and beginning the long acceleration toward light speed. At first, as you reach 10%, 20%, even 50% of light speed, the effect is subtle. Your ship behaves much as you'd expect. Applying more thrust makes you go faster, and the relationship between force and acceleration follows familiar patterns. But something interesting is happening beneath the surface. Your ship is becoming effectively heavier, requiring more and more energy to achieve the same incremental increases in speed. At 90% light speed, this effect becomes dramatically apparent. Your ship now has roughly twice its rest mass from the perspective of outside observers. The same rocket thrust that once provided vigorous acceleration now produces only modest increases in velocity. It's as if your ship is carrying an invisible cargo that grows heavier with every increase in speed, like climbing a mountain where each step adds another stone to your backpack. But this is only the beginning of the story. As you push toward 95% light speed, your effective mass increases to more than 3 times its rest value. At 99%, it's more than 7 times as heavy. At 99.9%, it's more than 22 times as massive. The curve of increasing mass rises steeper and steeper, like a mathematical cliff that becomes infinitely steep at exactly the speed of light. This growing burden of speed reveals why the light speed barrier is absolute for anything with mass. Each additional increment of velocity requires exponentially more energy, not just because you're already moving fast, but because your effective mass keeps increasing, making acceleration progressively more difficult. It's like trying to push a snowball up a hill where the snowball gets bigger with every step, eventually becoming so massive that no finite amount of force could push it any further. The energy requirements become staggering beyond imagination. To accelerate even a single proton, one of the smallest massive particles in existence, to 99.9999% of light speed requires the energy equivalent of lighting a 100-watt bulb for several minutes. To push it to exactly light speed would require infinite energy, which explains why this boundary can never be crossed by anything with mass. Amonantsen, emoj. With the meme suruten, emoben denden stray, twiden serverave is milli, say ye. Is sane demiluge, is milli. But here's what makes this even more remarkable. This isn't just a practical limitation based on the rockets or accelerators we can build. This is a fundamental feature of reality itself, written into the very structure of space-time. The universe has essentially decreed that the closer you get to light speed, the more reluctant matter becomes to go faster, as if reality itself is protecting the cosmic speed limit through this mechanism of increasing mass. From your perspective inside the accelerating spacecraft, something beautiful happens. You never feel heavier. Your bathroom scale would show exactly the same weight throughout your journey. Your body feels exactly the same mass. It always has. The increasing mass is only apparent to outside observers watching your journey. This preservation of your own experience while transforming how you appear to others is another example of the profound symmetry built into Einstein's relativity. This growing mass also affects the gravitational influence of fast-moving objects. A spacecraft traveling at 90% light speed has roughly twice the gravitational effect on nearby objects compared to when it was at rest, even though the particles making up the spacecraft haven't changed in any fundamental way. The additional mass energy of motion itself contributes to gravitational effects, revealing that gravity responds not just to rest mass, but to total energy. The phenomenon also demonstrates something profound about the relationship between matter and energy. The additional mass that appears at high speeds isn't really new matter being created. It's the energy of motion manifesting as effective mass. This is Einstein's famous E=mc² relationship in action, showing how energy and mass are different aspects of the same underlying reality. As particles approach light speed in accelerators, they demonstrate this mass increase in dramatic ways. Protons in the Large Hadron Collider become thousands of times more massive than their rest mass as they circulate at velocities incredibly close to light speed. This increased mass is what allows these tiny particles to carry enormous amounts of kinetic energy, enabling the high-energy collisions that reveal the fundamental structure of matter. Tonight, as you sit in the familiar comfort of your earthbound surroundings, every particle around you carries its rest mass with quiet constancy, but knowing that this mass could grow without limit, if accelerated toward light speed, adds a layer of wonder to the simple existence of matter itself, revealing that even the most basic properties we take for granted are actually dynamic features of reality that transform in the extreme realms approaching light speed. Deep within the heart of every atom, in the fierce nuclear furnaces of stars, and in the most powerful particle accelerators on Earth, one of the universe's most profound transformations takes place: the conversion of matter into pure energy and energy back into matter. This cosmic alchemy reveals that the distinction between mass and energy, which seems so absolute in our everyday experience, is really just a matter of perspective, two faces of a single unified reality. Einstein's most famous equation, E=mc², tells a story of incredible transformation. That little c², the speed of light multiplied by itself, is an enormous number, revealing that even tiny amounts of matter contain staggering quantities of energy. A single paperclip, if completely converted to energy, could power a large city for months. A grain of sand could provide enough energy to heat your home for years. This isn't science fiction. This is the actual energy content of ordinary matter, locked away in the very structure of atoms themselves. But how does this transformation actually happen? In the cores of stars, nuclear fusion performs this miracle every second of every day. 4 hydrogen nuclei, each carrying a tiny amount of mass, combine to form one helium nucleus. But the helium nucleus has slightly less mass than the 4 hydrogen nuclei that created it. That missing mass doesn't disappear. It transforms into energy, becoming the light and heat that makes stars shine and life on Earth possible. Every ray of sunlight that warms your face carries within it the transformed matter of hydrogen atoms that fused together in the sun's core, perhaps millions of years ago. The photons streaming through your window right now are the direct descendants of matter that once existed as atomic particles, but chose, through the magic of nuclear fusion, to become pure energy instead. In a very real sense, sunlight is matter that has learned to fly at the speed of light. This transformation works in reverse as well, though it requires tremendous energies to accomplish. In the most powerful particle accelerators, pure energy can spontaneously create matter and antimatter particles that pop into existence from the quantum vacuum. High-energy photons, particles of pure energy, can suddenly become electrons and positrons, matter and antimatter twins, born from light itself. Energy quite literally becomes matter, demonstrating that the boundary between them is more fluid than our everyday experience suggests. The relationship becomes even more beautiful when we consider annihilation, the process where matter and antimatter meet and transform completely into energy. When an electron encounters its antimatter twin, a positron, they don't simply cancel each other out. Instead, they perform the universe's most perfect disappearing act, converting their entire mass into photons that race away at light speed. Matter doesn't destroy matter, matter becomes light. This transformation reveals something profound about the nature of mass itself. The particles we think of as having mass, electrons, protons, neutrons, are really just stable patterns of energy that have temporarily chosen to move slower than light speed. Their mass is, in essence, trapped energy, energy that has taken on the characteristics we associate with matter: inertia, gravitational attraction, the ability to resist acceleration. But energy can also exist as mass-free radiation, photons that carry energy while having no rest mass at all. These particles of light exist in a realm where energy flows freely at light speed, unencumbered by the property of mass that keeps other forms of energy moving more slowly through space. Light is energy that has refused the burden of mass, energy that has chosen to travel at the universe's ultimate speed limit. The transformation between matter and energy also explains why nothing with mass can reach light speed. As particles accelerate toward the cosmic speed limit, their kinetic energy increases dramatically. But this energy manifests as increased mass, making further acceleration require ever more energy. It's as if the universe has created a cosmic recycling system where attempts to reach light speed by adding energy simply create more mass, which makes reaching light speed even more difficult. This recycling relationship suggests that mass and energy are really the same substance appearing in different forms, like water that can exist as liquid, ice, or vapor while remaining fundamentally acido. Harder is energy that has crystallized into slower-moving, more stable patterns. Energy is matter that has melted into its most fluid, fastest-moving form. The process also reveals why light speed is so fundamental to the structure of reality. The speed of light appears in Einstein's equation, not just as a number, but as the conversion factor between mass and energy, the cosmic exchange rate that determines how much energy is equivalent to any given amount of mass. In a sense, the speed of light is the universe's way of keeping its books balanced, ensuring that energy and mass can transform into each other while preserving the total amount of each. Even in the quantum realm, this transformation continues constantly. Virtual particles pop into existence from pure energy, exist for impossibly brief moments, then disappear back into energy. The vacuum of space itself seethes with these temporary materializations of energy into matter and matter back into energy, a cosmic dance of transformation that happens everywhere, all the time. As you sit surrounded by matter, the chair supporting you, the air you breathe, your own body, you're surrounded by crystallized energy, high light that has chosen to move slowly and take on the properties of mass. Every atom around you contains within it the potential to become pure light, pure energy racing away at the cosmic speed limit, returning to the luminous realm from which all matter ultimately emerged. Photons exist in a realm of pure possibility that matter can only dream of reaching, a realm where energy flows unencumbered by mass, where motion happens at the ultimate cosmic speed, where existence unfolds in timeless perfection. These particles of light offer us a glimpse into what reality looks like when freed from the gravitational burden that keeps everything else moving at pedestrian speeds through the cosmos. The photon's most remarkable gift is its complete lack of rest mass, while electrons, protons, and all the other building blocks of matter carry within them a fixed quantity of mass that can never be reduced to zero. Photons exist as pure energy without this fundamental property. They are energy in its most liberated form, unbound by the inertia that characterizes massive particles, free to move at the one speed that defines the structure of space-time itself. This masslessness isn't just a curious property, it's what allows photons to achieve what nothing else can: motion at exactly light speed, no faster, no slower. Unlike massive particles that can move at any speed from 0 up to, but never reaching light speed, photons have no choice in their velocity. They must travel at light speed from the moment they're created until the moment they're absorbed. It's as if they exist in a cosmic fast lane where slowing down simply isn't an option. But this constraint is also their freedom. Because photons have no mass, they require no energy to maintain their motion. A photon created in the heart of a distant star, billions of years ago, arrives at your eye with exactly the same energy it started with, assuming nothing absorbed it along the way. It never gets tired, never slows down, never needs additional energy to keep going. It exists in a state of perpetual, effortless motion that massive objects can only envy. Photon's massless existence also gives it a unique relationship with time itself. While massive objects experience the flow of time at rates that depend on their motion through space, photons exist outside temporal flow entirely. From a photon's perspective, if we can imagine such a thing, its entire journey from creation to absorption happens in a single, eternal instant. Time stops completely for light, creating a form of existence that transcends the temporal framework within which all massive matter must operate. This timeless existence means that photons carry information across the universe in what is, from their perspective, no time at all. When you see light from a star that's 1,000 light years away, you're receiving information that has traveled for a millennium from your perspective. But for the photons themselves, the delivery was instantaneous. They serve as the universe's most efficient messengers, connecting distant regions of space and time through their timeless existence. Photons also demonstrate perfect efficiency in energy transport. When a photon is created, whether in a nuclear reaction in a star's core, in the LED of your reading light, or in any other process, it carries away energy with no loss whatsoever. Unlike matter, which dissipates energy through friction, heat, and other interactions, photons transport their energy with perfect fidelity across any distance, arriving at their destination with their cargo intact. Whole. This perfect efficiency extends to their interactions with matter. When a photon encounters an electron in an atom, it can transfer all of its energy in a single, discrete transaction. The photon doesn't gradually slow down or partially transfer its energy. It gives everything it has and disappears, completely transforming its energy into the motion or excitation of the matter it encounters. It's an all-or-nothing existence that demonstrates a kind of cosmic generosity. The photon's massless nature also allows it to reveal the true geometry of spacetime, because photons always travel along the shortest possible paths through curved spacetime, what physicists call geodesics. They serve as cosmic surveyors, mapping the curvature created by massive objects. When light bends around stars or black holes, it's showing us the actual shape of spacetime itself, making visible the invisible gravitational architecture of the universe. Perhaps most remarkably, photons demonstrate that energy can exist in a pure state, unencumbered by any of the properties we usually associate with matter. They have no electric charge, no size in the conventional sense, no internal structure. They are, in essence, pure electromagnetic disturbance, propagating through space at the fundamental speed of reality itself. They show us what energy looks like when it's completely free to be itself. This purity also means that photons are perfectly democratic particles. It doesn't matter whether they were created in the most violent stellar explosion or the gentlest candle flame. All photons of the same energy are absolutely identical. There's no way to tell by examining a photon where it came from or what created it. This democratic nature means that light from the most distant galaxies is fundamentally the same as light from your bedside lamp. The photon's gift to our understanding is profound. It shows us that reality includes realms where mass, time, and many other properties we consider fundamental simply don't apply. Photons exist as living proof that the universe is far stranger and more varied than our matter-bound experience suggests, offering us glimpses into forms of existence that transcend the familiar categories of space, time, and substance. As countless photons stream through the darkness around you tonight, from stars, from electronics, from every illuminated surface, each one carries within its massless existence this gift of transcendence, this demonstration that reality includes perfect, timeless messengers, capable of connecting any 2 points in the universe instantaneously while carrying their energy cargo with perfect, generous efficiency across whatever cosmic distances separate light from light. In the familiar world of everyday experience, the order of events seems absolute and unchanging. First the match strikes, then the candle lights. First the apple falls, then it hits the ground. First you speak, then your voice reaches a listener's ears. This sequence feels so fundamental that we rarely question it. Cause precedes effect, and this ordering remains the same, regardless of who observes it. But as we venture into the realm of near-light speed travel, even this most basic aspect of reality begins to reveal surprising flexibility. Einstein's relativity shows us that the sequence of events isn't quite as fixed as our intuition suggests. While the order of causally connected events, where one event directly influences another, remains protected, events that are merely coincidental can appear to happen in different orders, depending on the observer's motion through space. This revelation opens up a strange and beautiful world, where simultaneity itself becomes relative, where now becomes a matter of perspective. Imagine two events happening in distant locations at what you, sitting quietly in your chair, would consider the same moment. Perhaps a star explodes in one galaxy at the exact same time that a planet forms in another galaxy, billions of light years away. Hawk. From your earthbound perspective, these events are perfectly simultaneous, happening in the same universal now that you experience. But now imagine an observer traveling at tremendous speed, perhaps 90% of light speed, in the direction from the exploding star toward the forming planet. From this traveler's perspective, something remarkable happens to the timing of these events. The simultaneity you observed from Earth becomes unstuck. The traveler might observe the star exploding first, followed by the planet's formation. The order has shifted, not because anything physical has changed about the events themselves, but because motion through space affects what different observers consider to be simultaneous. Even more remarkably, an observer traveling in the opposite direction, from the forming planet toward the exploding star, might see the events in yet another order, perhaps observing the planet formation before the stellar explosion. Three observers, each with equal claim to correctness, witness the same two events in different sequences. This isn't due to the finite speed of light creating delayed observations. This is a fundamental feature of how space-time itself is structured. This relativity of simultaneity might seem disturbing at first, suggesting that reality lacks a firm foundation. But the universe has built-in protections that prevent this flexibility from creating logical paradoxes. While unconnected events can appear in different orders to different observers, events that are causally linked, where one actually influences the other, maintain their proper sequence for all observers. Cause always precedes effect, regardless of how fast you're traveling or in which direction. The reason for this protection lies in the fundamental structure of space-time itself. Events that can influence each other must be connected by signals or influences traveling at or below the speed of light. This creates what physicists call light cones, regions of space-time that define which events can affect which other events. No matter how you move through space, you can never observe an effect happening before its cause if they're genuinely connected by physical influences. This protection of causality reveals something profound about the speed of light. It's not just a speed limit for matter and energy, but a cosmic fence that preserves the logical structure of reality itself. The universe seems to have chosen this particular speed limit precisely because it allows simultaneity to be flexible while keeping causality intact. It's as if reality is designed with just enough flexibility to accommodate different perspectives while maintaining enough structure to prevent logical contradictions. The implications become even more interesting when we consider communication between observers moving at high speeds relative to each other. If you send a radio message to a friend traveling at 90% of light speed, you might consider the sending and receiving of that message to be separated by several hours. But your friend, due to the relativity of simultaneity, might experience a completely different time interval between these events. Yet both of you would agree on the fundamental fact that the message was sent before it was received. This flexibility in the ordering of events also affects how we think about cosmic simultaneity. There is no universal now that applies everywhere in the universe at once. Instead, each observer carries their own version of now with them as they move through space-time. These different versions of simultaneity can slice through the universe's events in different ways, creating different perspectives on when things happen without violating the fundamental requirement that causes precede effects. The relativity of simultaneity also reveals something beautiful about the nature of observation itself. The act of observing isn't passive. Your motion through space affects what you consider to be happening now throughout the universe. In a sense, each observer creates their own version of cosmic time by their movement through space-time, their own perspective on the ordering of distant events. As you sit in your evening quiet, you carry with you your own slice of cosmic simultaneity, your own version of what's happening now throughout the universe. Other observers, moving differently through space, are experiencing their own versions of now that slice through the universe's events in slightly different ways. Yet all of these perspectives are equally valid, equally real, part of the rich tapestry of viewpoints that make up the full reality of space-time. In a universe where space contracts, time dilates, and simultaneity becomes relative, one principle remains absolute and unshakable. Information cannot travel faster than light. This cosmic speed limit for communication serves as the universe's way of maintaining order, ensuring that cause and effect maintain their proper relationship, even in the strange realm of near-light speed physics. To understand why this limit is so fundamental, imagine what would happen if information could travel faster than light. Picture yourself sending a message to a friend, traveling at high speed relative to you. If that message could somehow travel at twice the speed of light, something remarkable and disturbing would occur. Depending on the relative motions involved, your friend might receive the message before you sent it, from their perspective. This isn't just a theoretical curiosity. It would create a universe where effects could precede their causes, where logic itself would break down. The speed of light limit for information prevents this logical chaos. No matter how you arrange observers, no matter what their relative speeds, no matter which direction they're traveling, information transmitted at or below light speed always arrives after it was sent. The universe has essentially built causality protection into its fundamental structure by making the speed of information transmission finite and limited. This limit applies to all forms of information: radio waves, light beams, gravitational influences, quantum entanglement correlations, everything that could potentially carry a message from one place to another. Even gravity, which seems to act instantaneously in our everyday experience, actually propagates at exactly light speed. When the sun moves, Earth doesn't instantly feel the change in gravitational attraction. That information travels to us at the speed of light, taking the same 8 minutes that sunlight takes to make the journey. But this speed limit isn't just about preventing paradoxes. It also creates something beautiful, a cosmic communication network where every transmission has a travel time that depends on distance. This finite speed of information creates the possibility of past, present, and future. If information could travel infinitely fast, everything in the universe would happen simultaneously from every perspective, and time itself would become meaningless. The light speed limit for information also means that distant events don't affect us instantly. When a star explodes in a galaxy a million light-years away, that information, carried by light, gravitational waves, and other signals, takes a million years to reach us. During that million-year journey, we remain in a state of cosmic ignorance about the explosion, unable to be influenced by it until the information finally arrives. This creates what physicists call causal isolation, regions of space-time that are temporarily cut off from influencing each other until information has time to travel between them. Right now, there are countless events happening throughout the universe that cannot possibly affect you yet, because their information is still traveling toward Earth. You exist in a kind of causal bubble, influenced only by events whose information has had time to reach your location. The finite speed of information also reveals something profound about free will and determinism. If information could travel infinitely fast, the state of the entire universe might be determined instantaneously by events everywhere else. But because information takes time to travel, different regions of space can maintain some degree of independence from each other, at least temporarily. The universe isn't a single, instantly connected system. It's a collection of regions connected by information traveling at finite speed. Even quantum mechanics, with its strange, spooky action at a distance, respects this speed limit for information. And while quantum entangled particles can affect each other's properties instantaneously across vast distances, correlation cannot be used to send information faster than light. The universe seems to have built quantum mechanics in such a way that its strangest features don't violate the causality protection provided by the light speed information limit. This speed limit also shapes how we explore and understand the cosmos. Every observation we make of distant objects shows us those objects as they were when their light left them, not as they are now. We're constantly receiving information from the universe's past, building our understanding from signals that have traveled sometimes billions of years to reach us. Astronomy becomes a kind of cosmic archaeology, piecing together the history of the universe from ancient information still traveling toward us. The practical implications of this speed limit become apparent when we imagine interstellar communication. A conversation between Earth and a colony on a planet orbiting Proxima Centauri would involve 8-year delays, 4 years for your message to travel there, 4 years for the reply to come back. Normal conversation becomes impossible across interstellar distances. Instead, communication becomes more like leaving letters for future generations, messages sent into the cosmic postal system with years-long delivery times. But perhaps, most beautifully, this speed limit for information creates the possibility of surprise and discovery. Because information takes time to travel, the universe can surprise us with news from distant regions. Supernovae, gravitational wave signals, gamma-ray bursts, that represent information arriving from events that happened in our past, but are just now reaching us. Each astronomical observation is like opening a letter from cosmic history, information that has been traveling toward us through space and time. As photons stream through the darkness around you tonight, each one carries information at exactly the cosmic speed limit, neither faster nor slower. These messengers of light respect the fundamental rule that preserves causality and maintains the logical structure of reality, ensuring that information flows through the universe in an orderly fashion that keeps cause and effect in their proper relationship. The speed of light isn't merely an arbitrary cosmic traffic law. It's the fundamental organizing principle that keeps reality itself coherent, logical, and beautifully structured. This ultimate speed limit serves multiple profound purposes in maintaining the universe as a place where existence makes sense, where cause and effect flow in orderly sequences, and where consciousness itself can emerge from the complex dance of matter and energy across space and time. Consider what the universe would be like without this speed limit. If influences and information could travel infinitely fast, every event everywhere would instantly affect everything else throughout the cosmos. The formation of a galaxy in one corner of the universe would immediately influence the behavior of atoms in distant stellar systems. The universe would exist in a state of instantaneous, total connection, where nothing could develop independently, where no isolated systems could evolve their own characteristics over time. Such a universe would be strangely static, despite its infinite connectivity. Without the finite speed that creates delay between cause and effect, there would be no room for the gradual processes that allow complexity to emerge. Stars couldn't form slowly from collapsing gas clouds, because every particle would be immediately influenced by every other particle throughout the universe. Planets couldn't develop their own geological and atmospheric characteristics, because they would be instantly coupled to every cosmic influence. Life itself might be impossible in such a universe, because biological development requires the kind of local autonomy that only finite communication speeds can provide. The light speed limit creates something precious, the possibility of local causality. Within any given region of space, events can unfold according to local conditions without immediate interference from distant influences. This allows islands of complexity to develop, solar systems, planets, ecosystems, and eventually conscious observers who can contemplate the universe that gave birth to them. The finite speed of information creates cosmic privacy, regions where local physics can operate without instant cosmic supervision. This speed limit also enables the existence of time as we experience it. In a universe with infinitely fast information transfer, all events would be equally present to all observers. There would be no meaningful distinction between past, present, and future, because information about everything would arrive instantly. The finite speed of light creates temporal depth, allowing the universe to have a rich temporal structure where events unfold in meaningful sequences across time. The protection of causality through the light speed limit also preserves the possibility of scientific understanding itself. Science depends on the principle that identical causes produce identical effects, and that effects follow causes in predictable ways. If information could travel faster than light, this fundamental assumption would break down. Experiments could be affected by their own future results, making controlled investigation impossible. The universe would become logically incoherent, unsuitable for the development of rational understanding. But the cosmic speed limit does more than just prevent paradoxes. It creates the conditions for memory, learning, and consciousness. The finite speed of information means that the past genuinely differs from the present in terms of what information is available. This difference creates the possibility of historical records, of learning from experience, of building knowledge over time. Without this temporal structure, created by finite information speed, consciousness might have no foundation on which to develop. The speed limit also creates the phenomenon of cosmic horizons, boundaries beyond which we cannot see or influence. These horizons aren't limitations so much as they are gifts, creating a universe with mystery and depth. We exist within our cosmic light cone, the region of space-time from which information has had time to reach us, surrounded by vast realms that remain hidden beyond the horizon of light-speed communication. This creates a universe that can surprise us, teach us, reveal new wonders as information from previously hidden regions gradually reaches us. Even the expansion of the universe interacts beautifully with the light speed limit. As space expands, some regions of the cosmos move beyond our cosmic horizon, their information redshifted beyond detection. Meanwhile, new regions come into view as their ancient light finally reaches us after journeying for billions of years. The finite speed of light creates a dynamic, evolving view of the cosmos, where our observable universe gradually changes as information arrives from increasingly distant and ancient sources. The cosmic speed limit also provides a kind of cosmic justice. No observer, no matter how they move through space, can gain an unfair advantage over the fundamental structure of reality. While motion can affect the rate at which you experience time and the distances you measure, it cannot allow you to violate causality or receive information about events before they've had time to influence you through normal physical processes. Perhaps most profoundly, the light speed limit creates the conditions for meaning itself to exist in the universe. Meaning requires the possibility of genuine choice, genuine change, genuine development over time. In a universe with infinitely fast information transfer, everything would be predetermined by the instantaneous influence of everything else. But the finite speed of light creates space for local autonomy, for systems to develop their own characteristics, for consciousness to emerge and contemplate its place in the cosmic order. As you rest in your evening quiet, you exist within a universe whose structure is maintained by this fundamental speed limit. Every photon passing through your space respects this cosmic law, ensuring that your local environment can maintain its coherence, while remaining connected to the vast universe beyond, through the patient, orderly flow of information, traveling at light's unchanging pace, preserving the logical structure that makes your existence and your ability to contemplate that existence beautifully possible. In the quiet corners of theoretical physics, where mathematics meets imagination and possibility dances with impossibility, scientists have contemplated the existence of particles that live forever beyond the cosmic speed limit, hypothetical entities called tachyons that supposedly travel faster than light from the moment they're created. These phantom particles represent one of the most intriguing what-if scenarios in physics, forcing us to confront what reality might look like if the fundamental rules were somehow different. The word tachyon comes from the Greek word for swift, and these theoretical particles would indeed be swift beyond imagination, while ordinary matter can never reach light speed, because doing so would require infinite energy. Tachyons would exist in a mirror realm where slower speeds require infinite energy, and their natural state would be motion faster than light. In essence, tachyons would be trapped above the light barrier, just as we are trapped below it, unable to slow down to light speed any more than we can accelerate up to it. But contemplating tachyons immediately leads us into wonderfully strange territory. If such particles existed, they would experience time backwards from our perspective. A tachyon traveling from point A to point B would appear to arrive at point B before it left point A. This isn't just a quirk of observation, it's a fundamental consequence of how space-time geometry works for faster-than-light motion. Tachyons would live in a realm where cause and effect are reversed, where effects precede causes, where the arrow of time points in the opposite direction. Imagine trying to observe a tachyon's journey through space. You might first detect it, arriving at its destination, seemingly from nowhere. Only later would you observe it passing through intermediate points along its path. And finally, you would see it departing from its source. The entire journey would unfold backwards from your perspective, like watching a movie run in reverse, but with the understanding that this represents the tachyon's natural experience of time. This backwards flow of time creates immediate logical problems. If tachyons could carry information, they could theoretically allow communication with the past. You could send a tachyon message to a friend, who could then reply with their own tachyon message that arrives before you sent your original message. This creates the possibility of receiving replies before sending questions, of learning about the future, of creating the kind of causality paradoxes that make physicists deeply uncomfortable. The mathematical description of tachyons requires them to have imaginary mass, not imaginary in the sense of made up, but imaginary in the mathematical sense, where the mass would be described by imaginary numbers. This isn't necessarily a fatal flaw, as imaginary numbers appear throughout physics in useful ways, but it does suggest that tachyons, if they exist, would be fundamentally different from ordinary matter in ways that challenge our basic understanding of what particles are. Perhaps most troubling for the possibility of tachyon existence is what physicists call the tachyon instability. In quantum field theory, the presence of tachyonic particles in a system often indicates that the system is unstable and will spontaneously evolve toward a different state where tachyons don't exist. It's as if the universe naturally heals itself from the presence of faster-than-light particles, preventing them from maintaining stable existence. Some theories suggest that if tachyons ever existed, they would immediately cause the vacuum of space itself to decay into a lower energy state, potentially transforming the fundamental structure of reality throughout the universe. This vacuum decay would propagate outward at light speed, fundamentally altering the laws of physics in its wake. Such a scenario would make tachyons not just exotic particles, but potential harbingers of cosmic transformation. Yet the mathematical possibility of tachyons continues to intrigue physicists, because they represent a kind of completeness in our understanding of spacetime. If particles can travel slower than light, ordinary matter, and exactly at light speed, photons, mathematical symmetry suggests there should also be particles that travel faster than light. The fact that we've never observed tachyons might simply mean they don't interact with ordinary matter in detectable ways, or that they exist in domains of reality we haven't yet learned to explore. Some interpretations of quantum mechanics suggest that certain quantum effects might involve tachyonic virtual particles, particles that exist only briefly during quantum interactions and carry information faster than light, but in ways that can't be used for practical faster-than-light communication. These virtual tachyons would exist only in the hidden quantum realm, mediating interactions while remaining forever beyond direct observation. The search for tachyons also raises deep questions about the nature of scientific investigation itself. How do you look for particles that arrive before they depart? How do you design experiments to detect effects that precede their causes? The very concept of tachyons forces us to reconsider our assumptions about observation, measurement, and the relationship between theory and experiment. Sprawls, the Spirizes and mauve, the Firies and mauve. Perhaps most beautifully, tachyons remind us that our universe, however strange it seems in the realm of relativity and quantum mechanics, might actually be quite conservative compared to other possibilities. The absence of tachyons suggests that reality has chosen a particular set of rules that prioritize logical consistency over mathematical completeness, that preserve causality over symmetry, that maintain a universe where consciousness can emerge and contemplate its own existence without being overwhelmed by logical paradoxes. As you sit in your familiar world, where causes precede effects and time flows in one direction, the phantom possibility of tachyons adds a layer of appreciation for the logical structure of reality, for a universe that has apparently chosen coherence over exotic possibilities, maintaining the kind of ordered existence where contemplation itself becomes possible. In the deepest quantum realm, where particles exist in states of ghostly uncertainty until observed, there exists a phenomenon so strange that Einstein himself called it spooky action at a distance, quantum entanglement, where two particles can become so intimately connected that measuring one instantly affects the other, regardless of the distance separating them. This mysterious connection seems to violate our intuitive understanding of locality and the speed of light limit, yet it preserves the fundamental structure of causality in ways both subtle and beautiful. Imagine two particles born from the same quantum event, perhaps photons created when a single particle decays, or electrons produced in a carefully arranged laboratory interaction. These particles become entangled, sharing a quantum state that connects them in ways that seem to transcend space and time. When these particles separate and travel to distant locations, perhaps one to Earth and one to a laboratory on Mars, they maintain their mysterious connection. The strangeness reveals itself when you measure a property of one particle, perhaps its spin direction. The instant you perform this measurement, the other particle, millions of kilometers away, immediately knows what you've discovered and adjusts its own properties accordingly. If you find the first particle spinning clockwise, the second particle instantly becomes counterclockwise, not because any signal traveled between them, but because they share a single unified quantum state that encompasses both locations simultaneously. This instantaneous connection appears to violate the cosmic speed limit that governs everything else in the universe. No physical signal could travel from one particle to the other fast enough to coordinate their behavior, yet somehow they remain perfectly correlated across arbitrary distances. It's as if the particles remain two aspects of a single quantum entity that refuses to acknowledge the separations of space and time. Einstein and his colleagues proposed what seemed like a reasonable explanation. Perhaps the particles carried hidden information with them from the moment of their creation, like cosmic coins that were predetermined to show heads or tails when examined. These hidden variables would make the correlation seem less mysterious. The particles wouldn't really be communicating instantaneously. They would simply be revealing information they had carried all along. But in the 1960s, physicist John Bell developed a mathematical test that could distinguish between hidden variable theories and genuine quantum entanglement. When experiments based on Bell's inequalities were performed, they consistently violated the predictions of hidden variable theories and confirmed the reality of genuine quantum entanglement. The particles really do seem to share instantaneous connections that transcend space and time. Yet remarkably, this apparent violation of the light speed limit doesn't actually allow faster than light communication. While the particle's properties become correlated instantaneously, you cannot use this correlation to send information. When you measure your particle, you get what appears to be a random result, sometimes clockwise, sometimes counterclockwise, with no way to control which outcome occurs. Only when you later compare your results with measurements of the distant particle do you discover the correlation. This means you could never use entanglement to send a message. You can't force your particle to spin clockwise in order to make the distant particle spin counterclockwise. The quantum measurement process gives random results that happen to be correlated with equally random results far away. It's as if the universe allows instantaneous correlation while preventing instantaneous communication preserving the causal structure of space-time while permitting quantum mechanics to work its strange magic. The non-communication aspect of entanglement reveals something profound about the nature of information and reality. The instantaneous correlation seems to involve what physicists call non-local reality, aspects of quantum systems that exist beyond specific locations in space. So in Newmine, the non-communication aspect of entanglement reveals something profound about the nature of information. Yet this non-local reality cannot be harnessed to carry messages or influence distant events in controllable ways. It represents a deeper level of cosmic connection that operates beneath the surface of ordinary cause and effect. Modern quantum mechanics suggests that entanglement isn't really action at a distance at all, but rather the manifestation of quantum states that were never truly local to begin with. When particles become entangled, they don't remain separate entities that somehow communicate. They become aspects of a single quantum system that exists in a realm beyond ordinary space and time. The spooky action is really just the revelation of connections that existed all along in the quantum realm. This perspective suggests that space and time, while fundamental to our macroscopic experience, might be emergent properties that arise from deeper quantum connections. The universe, at its most fundamental level, might be far more interconnected than our everyday experience suggests, with entanglement representing glimpses of this underlying unity that connects all things. Entanglement also plays crucial roles in emerging quantum technologies. Quantum computers rely on entangled quantabits to perform calculations that would be impossible for classical computers. Quantum cryptography uses entangled particles to create communication channels that are fundamentally secure against eavesdropping. These applications harness the mysterious connections of quantum mechanics while respecting the light speed limit for practical information transfer. Perhaps most beautifully, quantum entanglement suggests that the universe contains levels of connection and correlation that transcend our ordinary concepts of space and time. While we experience reality as a collection of separate objects interacting across distances, the quantum realm reveals an underlying web of instantaneous correlations that connects particles and perhaps everything in ways that bridge apparent separations. So does Candace. While we experience reality as a collection of separations, while we experience reality as a collection of separate objects interacting across distances, the quantum realm reveals an underlying web of instantaneous correlations. As you sit surrounded by countless quantum particles, many of them likely entangled with distant partners throughout the universe, you exist within this web of mysterious connections. The electrons in your body, the photons streaming past, the very vacuum of space around you, all participate in quantum correlations that transcend ordinary notions of locality, while somehow preserving the causal structure that keeps reality coherent and comprehensible. Our journey through the realm of light speed has taken us from the familiar world of everyday experience into territories where time stops, space flattens, mass becomes energy, and causality itself requires cosmic protection. These discoveries about the nature of reality at light speed illuminate some of the deepest questions that conscious beings can ask about existence, meaning, and our place in the vast cosmic story that surrounds us. The speed of light emerges not just as a physical constant, but as a fundamental organizing principle that shapes the very possibility of existence as we know it. It creates the temporal structure that allows memory, learning, and consciousness to develop. It establishes the causal relationships that make scientific understanding possible. It provides the cosmic horizons that give the universe mystery and depth. In essence, the speed of light helps create a universe where beings like us can emerge and contemplate the cosmos that gave birth to them. This raises profound questions about the relationship between consciousness and cosmic structure. Why does the universe seem so perfectly tuned to allow the emergence of observers who can understand its laws? The speed of light, along with other fundamental constants, appears to be set at precisely the values needed to create a cosmos where complexity can develop, where life can emerge, where consciousness can evolve to the point of comprehending spacetime, relativity, and quantum mechanics. Perhaps consciousness and cosmic structure co-evolved in ways we're only beginning to understand. The universe's tendency toward increasing complexity, from simple hydrogen and helium after the Big Bang to the intricate structures of galaxies, stars, planets, and life, might be related to its fundamental constants being set at values that allow such complexity to emerge. The speed of light, in this view, isn't just a rule that consciousness must accept, but a cosmic parameter that helped make consciousness possible in the first place. Our exploration of light-speed physics also reveals the deep interconnectedness of seemingly separate phenomena: time and space, mass and energy, matter and radiation. All of these apparent dualities dissolve into unified descriptions when viewed from the perspective of relativity. This suggests that the universe at its deepest level might be far more unified than our everyday experience suggests, with the various aspects of reality representing different facets of a single underlying truth. The light speed limit itself embodies this unity. It's simultaneously the speed at which massless particles must travel, the cosmic speed limit for causality, the conversion factor between mass and energy, and the fundamental constant that determines the relationship between space and time. This convergence of roles suggests that the speed of light touches something essential about the mathematical structure of reality itself. But perhaps most mysteriously, our journey through light-speed physics reveals the extent to which reality depends on perspective and relationship. Time dilation, length contraction, the relativity of simultaneity, all of these effects show us that fundamental properties we consider absolute actually depend on motion, observation, and the relationship between observer and observed. This suggests that the universe might be far more participatory than we usually imagine, with consciousness and observation playing deeper roles in the structure of reality than classical physics suggested. This participatory aspect of reality becomes even more pronounced when we consider quantum mechanics and its relationship to light-speed physics. The quantum realm reveals correlations and connections that seem to transcend space and time while still respecting the causal structure that light-speed physics requires. Bestowal, the universe appears to be simultaneously more deeply connected and more carefully structured than either classical or quantum physics alone would suggest. These discoveries also illuminate the remarkable journey of light itself through cosmic time. Every photon that reaches your eyes tonight carries within its existence the entire 13.8 billion year history of the universe. Light from the cosmic microwave background, the afterglow of the Big Bang, has been traveling toward us since the universe first became transparent to light. In receiving this ancient radiation, we're directly observing the early universe, touching across time through the patient journey of massless particles that have maintained their timeless existence across cosmic epochs. This temporal reach of light suggests that we exist in a universe where past, present, and future are intimately connected through the flow of electromagnetic radiation. The light that illuminates your evening carries information from events throughout cosmic history, making you a participant in the universe's ongoing story of self-discovery. Through the light that reaches your eyes, the cosmos observes itself across space and time. Perhaps most profoundly, our exploration of light-speed physics suggests that reality is far stranger, more beautiful, and more deeply structured than our everyday experience indicates. The universe contains realms where time stops, where space flattens to nothing, where particles exist in timeless states of pure energy, where massive objects can never quite reach the speed that massless particles must always travel. These extremes aren't flaws or limitations. They're features of a cosmos whose mathematical elegance and physical beauty exceed our wildest imaginings. As you rest in your familiar three-dimensional space, moving through time at the gentle pace of 1 second per second, you're part of a universe whose true nature encompasses timeless realms, infinite energies, and connections that transcend ordinary space and time. The speed of light serves as both a cosmic speed limit and a cosmic bridge, connecting the world of matter, where consciousness dwells, with the realm of pure energy, where light exists in eternal, perfect motion. Tonight, as countless photons stream through the darkness around you, Each one carries within its existence proof that reality is far more magnificent than we usually dare to imagine, more deeply connected than we typically perceive, and more perfectly structured for the emergence of consciousness than we have yet fully comprehended. And so our gentle journey through the realm of lightspeed draws to its close, leaving us perhaps with a transformed sense of the universe that surrounds us even in our quiet, earthbound moments. We've traveled together from the familiar world where clocks tick steadily and space remains reliably three-dimensional, into realms where time stops, space flattens, and the very nature of existence transcends our everyday understanding. The speed of light reveals itself not as a mere cosmic speed limit, but as the fundamental rhythm that orchestrates the dance of space and time, matter and energy, cause and effect. In light's timeless realm, we glimpse a universe far stranger and more beautiful than our ordinary experience suggests. If you're still awake and listening, I'm mildly impressed by your dedication to cosmic contemplation, though I suppose I can't complain about an audience that refuses to drift off during discussions of space-time geometry. That's either very flattering or slightly concerning for my ability to provide soothing science. If you're still awake and listening, I'm mildly impressed by your dedication to cosmic contemplation, though I suppose Haitians have du vieux of your guerre. Before we part ways tonight, I'm curious, do you feel differently about light now, perhaps more aware of the cosmic messengers streaming past you in darkness? Please consider liking this video and subscribing if these midnight explorations of physics bring you any measure of wonder or peace. Your support helps these conversations reach other curious souls wandering through late-night questions about reality. May your dreams be filled with timeless photons and gentle relativity, and may you wake tomorrow with a deeper appreciation for the magnificent strangeness of the cosmos that calls you home.